Hey everyone, so today we are continuing with our functions unit. We're going to be solving for inputs of a function given the outputs. So just to be clear, in the past we were given a function and we were given the input and then we find the output. Today we're going to be doing the opposite. So just a little review, function notation is the way a function is written. It's read f of x if you see this f with parentheses x. So for example, this would read f of x equals 3x plus 1. So I just wanted to review that notation just so you know exactly what's going on. F of x is also the same as saying y equals. So we're going to see that in our examples. So keep that in mind. Okay, so solving for inputs of a function given the outputs. Here we have given h of x equals negative 2x plus 5. Solve for x when h of x is equal to 3. So, like we said before, f of x is the same as saying y. So we can rewrite this as y equals negative 2x plus 5, and then the same thing here. We don't have a number in here. Normally we did. We were given an input value. But in this case, we don't have the input, we have the output. So I'm going to just rewrite this as y equals 3. So instead of writing h of x, I'm just writing y. So that happened here with the function that was given to us, and it happened here. Okay, so that might make it a little easier to see what we're going to do next. We're going to set our function equal to the output value. So y is equal to 3, y is also equal to negative 2x plus 5. You can apply that method that we used when we were solving systems of equations. When we have two things that are equal to the same thing, we're able to set them equal to each other. So I'm going to set this negative 2x plus 5 equal to 3. So negative 2x plus 5 is equal to 3. So I'm setting the function equal to the output value. We're not inputting it because it's not an input. Now from here, we just solve for x using inverse operations, which we know how to do. We're going to subtract 5 on both sides. That cancels. So we get negative 2x is equal to 3 minus 5 is negative 2. Then let's divide this negative 2 on both sides. That cancels. We get x equals 1, positive 1. Okay, so that means if our y value is 3, our x value is 1. So now I'm going to check this, and it's really easy to check. We know what our input value is. Oops. So I'm going to just take that input value and plug it into the function. So I'm going to take this x, and I'm going to plug it in for x over here to see if we get 3. So negative 2 times 1 plus 5. Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3, which is the output that we wanted. Y is equal to 3, our output is 3. So when our input is 1, our output is 3. All right, let's look at another example here. So given f of x equals 1/2 x plus 6, solve for when f of x is equal to 10. So I'm going to start by setting both of these just equal to y because it's the same as saying y equals, and I think it makes it a little easier to figure out. And then we're going to just set them equal to each other and solve for x. There's a couple ways you can solve this equation because we have a fraction. You could multiply everything by 2 if you want to get rid of the fraction first. I think I'm going to just move the 6 over first. But either way would work. So you're left with 1/2 x is equal to 10 minus 6 is 4. And now to get rid of this fraction, we're going to do the opposite. We're going to use inverse operations, and I'm going to multiply by 2. So that cancels out, and we get x equals 4 times 2 is 8. Okay, so our input value here is 8, and our output value is 10. When we take 8, plug it in for our input, we're going to get 10. Okay, so follow these two rules, these two steps, when we are given an output and we're trying to find an input. Set the function equal to the output and solve for x.